Oh, forgot the microphone. Let's plug this in. There, that should sound a little better. All right, so we've already done a little bit of this coordinate geometry. Does anybody remember what we did when we did coordinate geometry? We talked about things having coordinates. Somebody just tell me anything that you know at all about coordinate geometry. We had a thing where we had a coordinate. What did we talk about when we had a coordinate? Had an x-axis, y-axis. That's good. Somebody else. Now it's starting to come back to you. A coordinate plane. Good. That's good. We had another name for it. Do you remember the other name? It was kind of a weird name named after a guy, some French guy hundreds of years ago. It's called a Cartesian plane. Do you remember that? Named after a guy named Rene Descartes. All right, so we had that. Kenzie, you had your hand up? Yeah, slope, okay, and points and midpoints. Remember all that stuff? Well, slope and midpoint is something that we don't want to forget. We didn't learn that stuff just so we could learn it then, take a test on it, and then forget about it, all right? It's going to come back, and today it's going to come back just a little bit today. And the two main things that we have to remember are the slope and the midpoint. So let's do a quick refresher here. The first thing, let's refresh on what the slope was. We had a formula. Well, actually, we had a letter that represented slope. Do you remember what the letter was? It was M. Yeah, it's weird that it's M and the word is slope, but I kind of remember it's M because it's like a mountain, okay? It goes up and down, all right? It's kind of what slopes do. It's not really what it stands for. It doesn't stand for mountain, but that's how I like to remember it, okay? And then we had a little formula for it. Let's write down the formula because we're going to have to use it again, all right? So we had, I think it was chapter 3 probably. We had a test, quizzes, and everything on slope and midpoints. So we're going to do a little bit of the same thing today. Do you remember what it was for slope? Give me the two words, blank over blank. Rise over run, okay? So I'm not going to write that down, but that should help you with this. That's right. So what do we do with the y's? Put them on top and we subtract them. Remember that? Okay. It wasn't that long ago, a few weeks ago maybe. All right. And then on the bottom, what do we have on the bottom? Right. x1 minus x2. All right. You could put y2 minus y1, x2 minus x1. Most books would do that. I don't know why, but I just like to go y1 minus y2. It doesn't matter what order. I've said this a bunch of times, probably dozens of times. It doesn't matter what order you subtract them as long as what? As long as you subtract the what? The x's in the same order. That's right, okay? If I subtract the y's, I got to subtract the x's. Put the y's on top, the x's on the bottom. All right? We good? I got paper towels here. That's all I got. So I'm just going to make up some points. What if you had like 3, 5, and I don't know, -2, 1? All right? Just make this off the top of my head. Take about 15 seconds. Ready? Go. Find the slope between those 2 points. Okay? Everybody do that in your notes. I'll wait. So you subtract the y values, put it on top. Then you subtract the x values, and then you put them on the bottom. Remember, the first one is the x, the second one is the y. This point, that's the x, and this is the y. Again, it doesn't matter what order you subtract them in. I always like to do just the first one minus the second one. Doesn't matter. So what do you have on top? 5 what? Minus 1. Good, because those are the y values, and I subtract them. Now, if I go the first one minus the second one, I got to do the same thing with the x's. All right, so this one's a little bit trickier because you got negatives in here. But what is that going to be? That's going to be 3 what? Minus -2. Okay? Remember, you subtract. That's why this subtraction's there. That's why this subtraction is there, because of my little equation, my little formula tells me to do that. So let's do the work on it. 5 minus 1 is 4. What's 3 minus -2? 6. I could see where you get 1 out of it. I don't see where you get a 6. You're not multiplying. Right. Remember what we do when it's a minus? Add a line and change the sign. What's the sign of this? It was negative, now it's positive. So basically, 3 minus negative 2 is the same exact thing as just 3 plus 2. What's 3 plus 2? Okay, so what's the slope? 4/5. Okay, and that's how you write a slope. You always write a slope as a fraction. Don't put this as a decimal. Okay, keep it as a fraction. Is that coming back to you? All right, so that's how we did slope. We had another thing to do. What was the second thing we had to do? The midpoint, okay? And we had another one. We had equation of a line, and we had the distance, okay, which, let's see. Yeah, we probably will do the distance as well. Yeah, we're going to do all three. So let's do all three right now. But let's go to midpoint since I talked about that. So let's do midpoint. And what we'll do is we'll take these 2 points right here, and we'll find the slope, we'll find the midpoint, and we'll find the distance between them, okay? And I don't know if all the numbers come out nice and easy, but I just picked those numbers off the top of my head. Remember how to find the midpoint. Well, the midpoint, as it says, is a point. So we need to have ordered pair, okay? And so we're going to have this, and we're going to have this. And it's the midpoint. So that means it's in the what? In the middle. So if I have a length right here, how do I find what's in the middle? I take half of it, right? Okay, so that's what I'm going to do. So first thing I do is I put a 2 here and a 2 here. Now, unlike the slope, what do you do to the top up here? You don't subtract. What do? You add them. Okay, so the first one, you add the x's. So I put x1 plus x2. It's kind of small. Sorry about that. Didn't leave myself much room here. But you add the x's together, x1 plus x2. Now, what do you do with the second part of it? Add the y's together. That's right, y1 plus y2. Yes? Can you split it? What do you mean split it? Sure. -4. What's -4 split in half? Divided by 2, and that's what? It's -2. Sure. All right, so midpoint. Let's do those same two numbers, or those same 2 points. All right, and find the midpoint between these 2 points. I got 3, 5, I got -2, 1. Again, this may not come out perfect, might come out with a fraction, but that's okay. So let's do the midpoint. So I put my parentheses, put a comma, I put this over 2, and I put this over 2. So how do we find the first part of the midpoint? We add the x's together. So instead of going 5 minus 1, which was the y's, first of all, I'm going to take the x's, I'm going to add them up. 3 plus -2. 3 plus -2. See that? I took the x's and I added them up. And then I divide by 2. But we got to add them first. Let's do the y's. What are my y values? 5 and 1. So what do I do with those two? I add them up. 5 plus 1. Okay? And then let's just simplify this. What's 3 plus -2? What? 3 plus -2. When you add, it's just the same as 3 minus 2. It's 1. Okay? The rule for addition is you subtract the numbers from each other, take the sign of the bigger number. So if I subtract these, that's 1. 3 is the bigger number, so it's positive, so my answer is positive. So it's 1. And it's over 2, so it's 1/2. What about this one? 5 plus 1 is 6. 6 over 2 is 3. So that's the midpoint right there. And again, what we're doing today, the reason I'm doing this is not just because I like this stuff so much, I want to go back and re-teach it again. It's because we're going to use this stuff for the lesson today. So this is just a refresher course. So that's the midpoint. What was the third thing that we can find? Find the distance. Okay, so if I give you 2 points, again, we'll use these points right here that we started with, and I asked you to find the distance, we have a formula for that. Now that formula is a little bit more involved than the other two, but do you remember what it is? I'll put D equals. A big old square root, right. So you got a big old square root, and then, remember I kind of put the shell of the formula? Remember me saying that all the time? So that's what it is. You put a plus in the middle, you got parentheses, and they're both being squared. Now, what do you put in the parentheses? On midpoint, we added the x's. On slope, we subtracted, right? We subtracted the x's, we subtracted the y's. What do you do with distance? You subtract. Okay, you subtract them. So you subtract the x's. So I just put x1 minus x2. And then what do you do here? Subtract what? The y's. Doesn't matter what order you subtract them in, because once you square them, that'll always make it a positive number. All right, let's put the numbers in. So put a big old square root. I'll finish up this little shell of the formula, or the equation. And then we're going to subtract the x's from each other. So come up here. Which one are the x's? The 3 and the what else? The negative 2. So it's 3 minus negative 2. We've already done that once up here, so we should be able to do that. And now, let's do the y's right here. So we subtract the y's. Again, we've already done it with this one, but it's just 5 minus 1. Okay? Equals, keep that square root there. And let's figure out what's inside of here. 3 minus a negative. We've done this once already. So I'm going to add the opposite, or add a line, change the sign. 3 plus 2 is 5, just like we did it earlier. And then you got to square it. What about this one? 5 minus 1. What's 5 minus 1? That's 4. But what do we have to do with that 4? We have to square that. So let's figure out what that is. What's 5 squared? 25. And what's 4 squared? 16. Can you add those two in your head? 41. So it's the square root of 41. Do I change that into a decimal or anything? No. Just leave it like that. Okay? Just leave it like this. Now, I know when you're looking at this, it doesn't make much sense on what the distance is, but it's like 6 point something. Now, why could I do that in my head? Why did I know that it's 6 point something? I don't know what, but I know it's 6 point something. Well, because if this was 7, it would be the square root of what? 40. What did you say? No, not 42. 49. The square root of 49 is 7, right? So it's smaller than 7, but it's bigger than what? 6. Why? Because what's the square root, or what is 6? It's the square root of what? 36. So 41 is between the square root of 36 and the square root of 49. Agreed? Square root of 36 is 6. The square root of 9 is 7. 41 lies in between here. So what's the square root of 41? It's 6 point something. And I don't know what that is, but if you had a calculator, anybody got a calculator with them handy? Okay, punch it in. What is it? Give me like 2 decimal places. 6.40. Okay. All right, so it's about 6.40. Now the decimals keep going, all right, but it just rounds to 6.40. Does the third one actually, what's the third number after 0? 3. Okay, so it does round to 6.40. Everybody good with that? So that's the length. If it asks for the distance of a line segment, it's like 6.4 or something, all right? Or we could just keep it the square root of 41. I'm perfectly fine if you keep it like that. We good? Have I put everybody to sleep yet? Looks like about half of you. All right. Now that's review. Let's find out why in the world are we doing that stuff right here. Well, I'm glad you asked, because here we go. What if I get big old line right here? Here's my x and y axis, okay? And I'm going to put some points in here. Let's put these in, I don't know, yellow. Oops, I don't want that yellow. Let's try this again. Let's click out of that. There we go. And let's make the next thing yellow. I'm not going to put like all the little marks here, just because it takes too long. Okay. So let's say I put a point here, and that point is -7, 1. Does that look about where -7, 1 would be? Right? If I started here, I would count 7, 1, 2, 3, 4, 5, 6, 7, and I go up 1. Okay? Everybody with me on that? The next one is 7, 3. So I'm going to go about the same distance. This might not be 100% accurate, but it'd be close enough. That's about 7. It's +7, +3. So I go +7, then up 3, probably around in there somewhere. Looks pretty close. All right, so that would be 7, 3. And then my other number is 1, -5. So 1, -5, I go 1 and then -5, I don't know, probably about in there somewhere, -1, 5. I guess I could have done this on nice graph paper, but that's okay. So what we're going to do, if you look at the title of this lesson, what did the title of the lesson say? Coordinate geometry. We already talked about the coordinate stuff, right, with the slope, midpoint, and distance. Of what, though? Of triangles. So guess what? I got 3 points. Guess what I can make out of this? Make a triangle. So let's do that. Let's connect from here to here. And let's connect from here to here. And then we'll do that. Might not be completely accurate, but it's pretty close. Okay? What they're going to ask you to do, and we're going to do this, I kind of took my time with showing you how to find the distance and slope and all that kind of stuff. But what they're going to do is this. They're going to ask you to find the distance, not of just one line or one segment or one side of the triangle. Guess what they're going to ask you to find the length of? All 3 sides. Okay, so that's what we're going to do. So let's do it kind of quick. But write it down. Actually, let's do the slope first. They ask for the slope first, then the length of each side. So let's do the slope. I'll do the slope right here. Okay? So we got 3 sides, don't we? And they label them A, B, C. They call this one A, they call this one B, and this one right here is C. So let's find the slope of AB. All right? So I'm going to put AB, put a little dot right there. So let's find the slope of AB. We should be able to do it pretty quick now. There's A, there's B. What do? Subtract the Y's, put them on top, subtract the X's, put them on the bottom. So what are my Y's with A and B? It's 1 minus 5. Everybody see that? That's my second part, so that's the Y. This is the second part, that's the Y. Let's do the X's now. Put it on the bottom. It's -7 minus -1. Let's see what we get. What's 1 minus 5? It's -4. -7 minus a negative. Minus negative. We've done this twice already. Add a line, change the sign. -7 plus 1 is -6. Let's simplify it. What's negative divided by negative? Positive. And can we simplify 4 over 6? 2 over 3. Okay? There's a reason why we're doing this. Okay? So bear with me. I'll just keep it right there. I think we can fit everything in here. So that's one of the sides, AB. So we got the slope of it. It's 2/3. All right? Let's find the slope of the other 2. Let's do BC next. So let's do BC. I'll tell you what. I'm going to give you exactly 1 minute. See if you can find the slope of both of those other sides. Okay? I want you to do it instead of just watching me the whole time. Okay, everybody ready? I'll give you 1 minute. Go. 30 seconds for each. So find the slope of BC and then of AC. Let's go. Where are you going, though? All right. You know I'm going to talk to her, right? Okay.
Talk to the people at the front desk because the nurse is probably bored.
You got 15 seconds left. Five seconds. Anybody find both slopes? Did you find one? What was BC? What was the slope of BC? Okay, remember I didn't say this, but keep it as an improper fraction. Keep it as an improper fraction. What'd you get? Yeah, but reduce it. Yeah, always reduce. 4 over 3, okay? I'm not going to do the work. I just did it up here. You do the work to get 4/3, okay? And then what about the other one? AC. Anybody get that one? This one right here, that slope? Go ahead. Okay. What is it? Yeah, you did it the wrong way. You got to do the y's on top. The y's have to be on top. I think you put the x's on top. 1 over 7. Okay, so the slope of AC is 1 over 7. Remember, it's rise over run. The y's have to be on the top. The x's have to be on the bottom. Okay, so those are your slopes. We're going to get back to that in a few minutes, okay? But just hang on to them. Okay, these are going to be important to see. Because we're doing all this to show you something that I think is pretty important, according to this little theorem or definition or whatever you want to call it. Let's do the distance now. Distance takes a little bit longer. Slope should be really easy to find. If you're still working on that, that's what you should get for those slopes. Okay, now let's do the distance. Again, let's do the distance of AB first, then we'll do BC, and then we'll do AC. So let's find the distance between A and B. So the distance equals big old square root. This is squared plus this is squared. And what do? We just subtract the x's and put them in the first parentheses. So again, we're doing AB. We're going from here to here. So what are the x's? -7 and -1. Add those or subtract those from each other. So -7 minus -1. Didn't leave myself much room again, but we'll do that in a second. And then let's do the y's and put them right here. Subtract the y's from each other. It's 1 minus 5. 1 minus 5. Okay? -7 minus -1. Well, add a line, change the sign. It's -7 plus 1, which is -6. Let's do that in our head. What's -6 squared? And really, the negative doesn't make any difference. It's going to be 36. It doesn't matter if you square a negative or you square a positive, you're going to get 36. What about here? 1 minus 5. That's -4. Square -4, you get 16. So 16 goes right here. And so what is this? 36 and 16, that's 12, carry a 1, 52. Square root of 52. Did I mess up? I think I messed up.
You can't do that, you're a teacher.
Oh, you know what I did? Oh, my word. I really messed everything up. Right from the beginning, I messed it up. Look what I did. Look at point B. That's not -1,5. Look, I was here. It's not -1. -1,5 would be way up here, wouldn't it? Oh, my word. I messed everything up. Maybe that's why you weren't getting the same answers as I was getting over here. I don't know. But I still got this right. Well, you could still get the slope right, even if I got that. So these could still be okay. Oh, my goodness, I messed this up. So this shouldn't be -1,5. It should be what? Should be +1 what? -5. So let's try that one more time. Sorry about that. Oh, my word. Nobody caught that? You did? You should say something. I've made... Oh, after you finish doing it? Okay. My bad. Oops, I don't need it to go that long. Okay, let's try this one more time. Just shows I can make mistakes as well. And I do quite often. So anyway, this is 1 -5. Let's try it again. So we subtract the x's from each other. I'm doing AB. So subtract the x's. It's -7 minus 1. -7 minus 1. This will come out a lot nicer, I promise. And then you subtract the y's from each other. It's 1 minus -5. 1 minus -5. I'll just write it down here. -7 minus 1, add a line, change the sign. That's -8. -8 squared is 64. 1 minus -5, add a line, change the sign. The 1 plus 5 is 6. 6 squared is 36. You've seen this one before, haven't you? What's 64 and 36? That's 100. And what's the square root of 100?
10.
It's 10. Right. If it comes out even, you should always write it even. Okay? And it does. It comes out to a nice whole number, 10. So that's the length of AB right there. It's 10. Everybody with me? Okay. I know this is a long way to get to where we're going, but just hang on. I promise it'll work out. I'll tell you what. Let me just get rid of all this. And then I'm just going to scooch this up just so I have room so you can see everything. Okay? So we've done one side. So we did AB, the distance of AB. So let's find BC this time. Let's find BC. BC, the distance. So square root, right? After you do this 3 times, you should have this thing memorized as far as the distance formula. So BC, what do? We subtract the x's from each other. It's positive 1 and positive 7. Again, it doesn't matter what order you subtract them. You could go 1 minus 7 or you could go 7 minus 1, right? You want to go 7 minus 1? Make it a little easier. Then you got negative 5 minus 3, or you could go 3 minus negative 5. It doesn't matter what order you subtract them in. Let's see what we get. 7 minus 1 is 6. 6 squared is 36. 3 minus a negative. Minus a negative is always what? It's just plus. That's 8. 8 squared is 64. Guess what? We get the same thing, don't we? So 2 of these sides must be the same length. So AB and BC must be the same length. This one right here and this one right here. They kind of look it, don't they? All right. Yep. All right. What's the next one? AC. Let's find AC. All right. So we put a big old square root. We got parentheses and a squared plus parentheses and a squared. Let's do the same thing with AC. Again, what do we do inside the first one? Subtract the x's from each other. So I got negative 7 minus 7. Let's put it right here. Negative 7 minus 7. Let's do the y's. It's 1 and 3. So it's 1 minus 3. What's negative 7 minus 7? Can you do that in your head? Add a line, change the sign? No, it would be the same as negative 7 plus negative 7. It's negative 14. By the way, I forgot the square root right there. Shame on me. I am off. So now, negative 14 squared, I don't know what that is off the top of my head. It's 196, okay? So it's 196. That's 14 squared. Everybody got that? Okay, put in your calculator. It's 196. It's on my notes, so that's why I knew that. 1 minus 3 is negative 2, right? So negative 2 squared is 4. So what's 196 plus 4?
100.
It's 200. It's the square root. And I don't want to confuse you anymore. I'm going to do it anyway. This is something you should have learned in Algebra 1. Watch. 100 times 2 is 200. Would you agree? You learned something in Algebra 1 with square roots? Come on, let's look. Everybody look up here. Bryce, I'm talking to you. So what we can do is we can take this and make it the square root of 100 times the square root of 2. Do you remember doing this in Algebra 1? You didn't do any square root stuff in Algebra 1? Yeah, you should have. Now you know. Now you're learning it, okay? I'm not going to make you do this part right here, though. Now, the square root of 100, you should know is 10. You should definitely know that. The square root of 200, I'm not going to make you do what I'm doing, but I'm just going to show you how they write the answer. What's the square root of 100? It's 10, and then you just put times the square root of 2. So that is the simplest version of how long AC is. I know it doesn't make much sense to you. Don't worry about it. Don't let that bother you, all right? But that's good enough. So what do we have now? Does the bell ring at 15 on Wednesday? Yeah, so it's about to ring. So let's put some stuff in here that we know. Let's put the distance in here. So how long is AB? It's 10, isn't it? How long is BC? It's what? It's 10. And how long is AC? It's 10 times the square root of 2. Okay? And you know the slopes as well, okay? But what we're going to do tomorrow, we'll finish this up tomorrow. What we're going to do is we're going to find the midpoints as well. And then there's going to be really something that's kind of interesting about the midpoints and everything else, okay?